Hi everyone, welcome to this session. So today we will solve this problem. So read the question first. Select the correct frequency response at the output V0 when the circuit is excited by a current source. So this is a current source. Okay, this is a current source. Let's say I. So here we have output as voltage and current input as current. Okay, let's say I0. So what will be the transfer function in this case, like what will be the unit of this transfer function? So the unit of this transfer function will be ohm, right, in the ohm unit. So and to to solve this type of problems you can use Laplace domain analysis, or you can do the intuition first. Okay, so in this video we will try to solve this by intuition. Okay. So we know that for infinite frequency, capacitor acts as a short circuit. Okay, capacitor acts as a short circuit, we know that. And for like at DC, the capacitor acts as a open circuit. And let the transfer function of this block, like we know that if this is a black box and here we are giving input, here giving output, so this is our transfer function, let's say H. Okay, so here H is the combination of two parallel impedances. So let's say okay, let's forget let this is R2 and parallel with, let this combination is Rx. Okay, so this is our transfer function. Okay, so the unit of this transfer function is ohm. Okay, so let's predict the output waveform. So at t equals, like for f equals 0, so this is our f equals 0, this is f equals infinity, and similarly f equals 0 and f equals infinity. So let's predict the waveform at f equals 0. So at f equals 0, the capacitor is open circuit. Okay, so this is open, means the effective like transfer function is nothing but R2 itself. Okay, and R2 value is 10. Okay, so we can see that at f equals 0, the effective transfer function, like amplitude of the transfer function, is nothing but R2, we can say that. Okay, now let's see what will be happening at f equals infinity. So at f equals infinity, so this becomes short circuited. Okay, so what will be the like transfer function value? This will be nothing but H will be parallel combination of R1 and R2. Okay, and this will be nothing but the lowest impedance, like lowest resistance of this combination. So this will be around 1. Okay, so we can see that at f equals 0, the output is around 10, and at f equals infinity, the output is around 1. So we can see that at f equals 0, the output is high. So let's see what is high value. And f equals to 0, output is high, and f equals to infinity, output is very low. So let's see in this picture which has its similar functionality. So we can see that option 4 has, at f equals 0, input is high, and at f equals infinity, input is low. But in this case we can see that like input at f equals 0, output is high, but not in the constant at f equals infinity. And similarly we can see that here this is here this is low and this is also low, this cannot be the answer. And here we can see that this is high but this is low. Okay, but this is not the constant. Okay, so we know that at f equals infinity, the output will be around 1 and this will be constant. So we can see that option 4 is our option 4 is our answer, because it is fulfilling our criteria. Like at f equals 0, the output is very high, this is around 10, let's say. And f equals infinity, the output is around 1, so this is constant, right? So why this is happening? Like this is what is the inside of the circuit? Because we can see that here on pole and 0 is present. Okay, here on pole and 0 is present, but like if 0 and pole is present, which is the lowest value, okay, which is the lowest value, we can see that here the gain is constant and then a dip of minus 20 dB per decade. So here our poles come first, so this will be our omega p, and after some time the slope becomes 0. It means here there will be a 0, so that minus 20 dB, and for 0 this will be plus 20 dB, so the slope is 0, so this is 0 slope, right? So our omega zero frequency present at higher frequency, and you can do the same analysis using this writing this transfer function as well. You will find that zero value will be more than pole value, okay, so you can solve this. So here in this case our option 4 is the correct answer, and we solve this by intuition, okay, without writing any equations. So thank you. If you like our video, you can subscribe our channel. Thank you, and always put your valuable suggestions.